Okay, top of the hour. You've seen the agenda. I've posted it to the list. It's been posted at the IETF site for meeting material site for a while. And okay, now a new deck is being shared. That's the note well. Okay, yeah, if anybody hasn't seen that, go ahead.
Yeah, let's start up the meeting.
Yeah, we should. So if anybody has never seen a note well before, I recommend that you read it carefully.
Okay. And let's take a look at the agenda. The first presenter is?
Now I think we can move on from that. The first agenda item is
deployment status.
Why do I not? Okay, hold on. What do you have in mind?
This is Paulo. Sorry, just to jump in. I guess I'm the first speaker, so I guess I
yes.
Hello.
To ask for sharing slides. I think.
Okay, I will share your slides for you.
Okay, I guess he dropped out of the queue.
There you go. Can you see your slides?
Apparently not. At least not myself.
Oh, okay. Hang on a second.
Okay, so
hang on.
The first discussion we're going to have, I want to spend about 10 minutes on, or 15 minutes on this IP deployment status draft. Who is presenting that?
So, hello, this is Paulo. Just let me switch on my video so you can see me. All right. So basically, this is the update of the deployment status about IPv6, and I'm presenting on behalf of the authors named on this first slide. Ron, if you can go to the next one, please. Okay, so history of the draft. We submitted the the individual draft in October last year. We had a couple of revisions. Probably you remember that after IETF 110, there was the week requested by the chairs to exchange comments, and after that, I think the list decided to adopt as a workgroup draft. There was in June a question by the chairs to, let's say, check again if that was the case. So based on what we saw in the list in the past few weeks, our assumption is that the draft has been adopted, but of course we are open just to discuss it if there is any pending issues. Next one, please. Okay, status. We have added 3 more co-authors from the previous version. Let's say that thanks to the many comments we have received in the list, we tried to do our best to review entirely the draft, and you see we have grouped all the comments received in 4 major areas. The first one being removing let's say what is considered the marketing sales language, specify a bit better the scope of the draft, remove some unreferenced or unproven advantages of IPv6 that were explained but probably not referenced the proper way, and introduce some missing references. So again, thanks for everyone who spent time to review and comment the paper. Apart from that, we also presented the result of our analysis and the draft at RIPE 82, just to create some background around this draft. Next one, please. Okay, so you see here the main differences between version 01 and version version 02. Basically, we have maintained the overall structure of the draft. We changed some specific sections, and all those sections are highlighted in light blue. You see there. I would say main intervention in the text, we have rewritten the introduction, and we changed the final part of the draft that was called call for action into something that probably is more accepted by the community, which is common IPv6 challenges. And I'm going to explain just in the next few slides. Next one, please, Ron. Okay, something about the changes. We received some comments about the surveys we have described in the paper. There's one for network operators and one for enterprises. We have widened a bit the description of the surveys, and I'm going to talk about that in the next slide. Then we have differentiated between the usage of IPv6 only. At the service layer, we call it overlay, and in the physical network, so in the underlay. And by the way, the section about the underlay has been improved quite a lot, thanks to the help of Gian of Verizon. And we have better clarified, let's say, the description about the challenges which are contained in the final section of the draft. Next one, please. Now, about the survey, we think that all the comments have been addressed in this new version of the draft. Somebody, let's say, pointed out that probably it was not completely clear. Let's say the poll that we did last year didn't cover actually the majority of network operators. So say that looking at the customers of the operators we have interviewed, let's say the number is quite high. Our feeling is that probably now it should be, let's say, suitable for the draft. But if anything is still missing or something is not completely clear, we are open to discuss again. And we are also proposing, if you think that they could be even enlarged in its scope, we could propose a poll even through the V6OPS mailing list, just to get more feedback and more input. Next one, please. Now, challenges. I'm not going through the entire list of the challenges that we have listed in the draft, but basically you see that we try to point out what is still missing, what it's perceived as probably the factor that is still hindering the deployment of IPv6. We touched, let's say, almost all the technology and operational areas, including service providers, enterprises, devices, governments, and then moving to the operational side, so management, performance, security, and so on. And next one, please. Okay, so next steps. Again, we are completely open to receive feedback and criticism as usual. What is still missing in the draft? Probably we have still to complete a bit or elaborate on a bit one specific section about the incentives to IPv6. So any comment here is really welcome. And then one point that we discussed, let's say, when reviewing the text is there any operational input which is missing? So in case, feel free just to send an email and exchange the material that could be relevant for the discussion. And then one final question, which is actually for, again, for the audience, whether it makes sense to share this analysis externally. I mean, not just advertising V6OPS as yet another draft, but if it could be meaningful to say, well, there is, let's say, an analysis which is addressing the status of IPv6 and let's say, use as a basis for further discussions. I would say this is all on my side, so thank you, and clearly I'm open to any questions.
I don't see anyone in the queue. Are there any questions? Fred, any comments? And yes, Barbara, if you could help with the notes, I'd really appreciate it. Okay, I guess there are no questions.
Okay, so we are done, I think.
Okay, and we are done. So I will sharing.
Thanks.
Look for the next draft, which is pros and cons of IPv6 transition technologies. Let me share that deck.
Hello, can you hear me?
Yes.
I'm Gábor Lencse from Hungary. So I can't see yet the slides.
Hang on a second.
Yes, I can see the slides.
Okay.
I hope others do. So regarding our draft, we have one extremely important question. This is when to initiate the working group last call. Could you please go to the next slide? Thank you. So on the one hand, this draft should be published as soon as possible to assist network operators with a stable document. And on the other hand, our draft has yet two incomplete parts. One of them is section 5, which is currently a stub. It would be about benchmarking different implementations of all the 5 IP versions 4 as a service technologies. However, it would last 2 or 3 more years to do it because most RFC 8219 testers are yet to be implemented. And I understand that it is way too long. We discussed it with the authors and with the working group chairs that we may not wait so long time. So it must be left out. And we recommend to put a pointer to a new draft, which will be about this topic. And the other issue is it's not so easy because there's a undecided question in section 4.2. It's about the scalability of the stateful technologies. And I think that meaningful results can be produced for the next IETF meeting. And we recommended that for the working group chairs who accepted it. However, I would like to have the consent of the entire working group to wait until the next IETF, or just to leave it out and put a pointer for that too and start the working group last call. So before you could make a logical decision, you should know what this measurement would imply and how much useful they could be. So please go to the next slide. Yes. So what should be measured or what could be measured? Of course, we are talking about 5 IP version 4 as a service technologies. And of the 5, there are 2 we call stateful because they have state in the core network. One of them is 464 XLAT, which is a combination of stateless NAT46 and stateful NAT64. And we have a methodology and an RFC 8219 compliant tester for benchmarking these stateful NAT64 implementations. However, we do not have a tester for DS Lite. So we hope that representing the class by NAT64, we could give meaningful answers to the question, but it's up to you if you accept this answer or not. So please go to the next slide. And here's our draft, which was proposed. It's benchmarking methodology for stateful NAT-XY. It could be 64 and another else. Gateways using RFC 4814 pseudorandom port numbers. And this is the draft. I presented it on Monday in benchmarking working group. And it has one implementation, which is working, and one partial documentation, which is a draft paper. So I can use it. It was written by me. I can take measurement with this software. Could you go to the next slide? So the question is, what can be measured and how can we use it for making a decision? So what we can measure is how the number of connections stored in the stateful NAT64 gateway influence the throughput of the stateful gateway. So what parameters could we use? We can specify the exact port ranges for what source port to what first source port, last source port, and the same for destination port. And if you multiply with the size of the source port range with the size of the destination port range, you can calculate the number of combinations, potential number of connections to be stored in a stateful gateway. So I've tested this tester in a self-test setup up to 400 million combinations. It worked. And could you go to the next slide? Yes. So it's just an artwork. It's not results, but I could produce such kind of results. So on the horizontal axis, you can see the number of connections in the stateful gateway. Let's say from 1 million to 1 billion. And on the vertical axis, you can see the throughput in million frames per second. So I just draw two extremes. The blue one shows good scale up because the throughput doesn't really decreases with the huge increase of the number of connections. And the other is the very bad scale up because the throughput decreases significantly. So we could see something like this kind of results. Could you please the next slide? Yes. And the challenge is what parameters should we use to provide meaningful results for the network operators? For example, the range of the number of connections from 1 million to 1 billion, is it okay? And if you want more, how it breaks down to source port range, destination port range, what frame size to use, what NAT64 implementations to use. I could use some free software such as Joule, or is it enough to use a 10 gigabit per second Ethernet because I have no faster than that? So these are details. They could be discussed on the mailing list. However, the question you should decide is on the next slide. Could you go to the next slide? So it is very clear that either we go option A or option B. Option A means that we include the scale-up test, and I hope to perform the measurement before the next IETF meeting. And for this reason, we delay the working group last call until that time, and we include the scale-up test results. Option B, we leave out the scale-up test, and we just add the pointer to a new draft, and we can initiate the working group last call right now, I mean next week. So I give back the mic to the working group chairs, and please make a decision which is supported by the entire working group, what to do.
Okay, and I'm seeing a rather long queue here. So, Mackerman, would you like to go first?
Thank you, and I'd like to thank you for the great work. It's going to be helpful to those of us enterprises deploying IPv6 when we finally really do so. So I thank you in advance. My question is, I'm very much in favor of the scalability testing. And my question is, would that include CGNs? And again, thank you.
Would that include?
Carrier grade NAT.
If you wish, yes, it can. So I didn't think of carrier grade NAT because I was thinking about NAT64, but my tester is able to test NAT44. I have just performed some measurements with IP tables. It was suitable for that. Works with that. So if it is useful for the working group, I can do both measurements too. Yeah.
So Mike,
let me elaborate
you
just
would
a
be.
sec.
Mike, I
Go ahead,
think you
Fred.
would be asking for NAT64 testing, would you not?
Well, he mentioned that in his slides, and I just wondered, does that include CGNs? Reason is, I think a lot of us don't want to do this on our own, and we'll back into letting the carrier do it for us. And I've heard some real bad horror stories there, and if they're true, we certainly want to be aware of it.
Okay.
So sure, I can do both NAT64 and 44. I'm happy to do that, both.
Okay.
For this great work, appreciate it.
Changfeng.
Thank you, Chair. I have a comment about net weight 4/6. I think that it is stateful, not stiffness, which is the same to this night. As far as I know, that the difference between them is that there was only one state for net weight of over 6 on the network side, but there are multiple states for each user in this night. That's my comment. Thank you.
Okay. Edward, any response?
Okay.
Okay. Edward?
I have a question about a couple of previous slides, because I have seen some parameters which is accounted for, but as I understand, for any stateful device, and here we have definitely stateful device, we have 4 primary parameters which should be accounted. Of course, it's gigabits per second, it's packets per second, it's sessions per second, and it's upper limit of active sessions, 4 parameters. The active limits of sessions is just memory. It's typically not much related, but the previous 3, especially the one which is missing on all slides, is missing sessions, new sessions per second. It's really affect the performance. You could not test just one parameter. It does not make sense. You should try to understand for some particular scenario, for some particular use case, what is the combination of session per second, gigabit per second, packet per second, and try to establish all parameters at the same time. Only in this case, your measurement will make sense, because if you will measure just one parameter, it does not make sense. It's stateful device is very much affected by all 3.
Yes, I completely agree with you. I have shown you a link about a draft paper. In that paper, I made some measurements, and even the measurement method, which I don't want to detail, it has 2 phases. The first phase is, I call it preliminary phase, when we fill up the state table of the tester and also the connection tracking table of the stateful NAT device. And I have made some experiments, and I experienced that the connection establishment rate is lower than the throughput. I mean that if I have to fill in the state table, and every packet belongs to a new connection, it's lower rate than when the state table is already filled and I just send packets through existing connections. So I'm aware of this situation, and of course we can test different combinations. However, my experience says that we may test only a few combinations, otherwise, because there are so many parameters, and if we prepare the Cartesian products, that every let's say one parameter may have 3 values, the other may have 4 values, and we have 5 parameters, and we combine all possibilities. It is a so huge amount of measurements that it's for weeks or for months to execute them. So we have to.
You don't need too much. You don't need too much. You just need to assume a couple of use cases. For example, use case mobile traffic, use case fixed broadband traffic. Maybe a couple of different scenarios. You should assume, from my point of view, a few typical scenarios. 10 years ago back, I had such experience, and 10 years ago back, I had understanding what is the typical relationship between CPS, PPS, and GBPS for mobile, and what is the typical case of fixed broadband. I am not sure that I know current numbers because traffic may change a little bit, but you should just assume a few typical use cases, maybe additional use case enterprise, for example, big corporation, additional use case. Then after you will assume typical use cases, then you could test just these 3 or 4 use cases, not 100.
Well, I'm smiling because this is what I want from the working group. As you know, I'm an academic researcher, and this is what I don't have, the typical numbers, typical use cases. So if you can, so others can tell me this one, I'm very happy with that, and I'm happy to make the measurements according to your parameters. I'm very happy with that.
Okay, Jordi.
I as a co-author, I just want to say something about the first 2 questions that have been placed. The one about the CGN, we need to understand that this document is only about IPv6 only networks. So yes, NAT64 is covered, of course, but CGN should not be covered. Now, I am happy that we include it if we want to use it just as a comparison point, but not as a main question of the draft, because then the draft is totally different, right? Then the second point I want to make is about, if I understood correctly, it was mentioned that Lightwave 4/6 is stateful, and it's not, because we are talking about the state in the network, not in the CPE. And in Lightwave 4/6, the state is in the CPE in terms of performance. Okay, so just wanted to clarify that. Thank you.
Okay.
Okay. I have one quick question, Gabor.
Yes.
Have any of these test methods been socialized with BMWG?
Well, I have just shared the method, and all my 15 minutes were over. So I have already shared the draft about maybe 6 weeks ago. So I have got some answers on the BMWG mailing list, but at the meeting I don't have any comments because we have run out. Maybe because we have run out of the time, but maybe there were no comments.
Excellent, excellent. Okay, anything else on this draft? Fred? Nothing? Okay, in that case, we will go to the next draft for Edvard.
Hello, everybody.
Okay, ready?
Yes, go next, please. Recently, we have seen a little bit more activity than typically for oversized for MTU problem. It's probably because we have developed, especially last years, have developed a lot of new headers. It's IOM, it's SRv6, it's a different extension headers, which after applied in the network, a little bit additional challenge, additional to typical tunneling, additional challenge, which probably explains why we have a little bit more interest recently. Additional problem, which may be already old enough but not very well discussed, is a problem about equal cost multipath. Because if you look to any current network, you will see that on many links you have ineffectively many Ethernet links in parallel, up to 16, maybe 4, 8 is typical. I have seen personally for one more or less big network for 5 hops, the combination which gives 64,000 of different paths possible just between 2 points through the network, because 5 hops and 1 hop 4 parallel links, next hop 8 parallel links, and additionally there is some ECMP between different nodes, and then as a result 64 as a result huge. In such a situation, the path MTU could change dynamically and could change abruptly. It's additional probably challenge which happened recently. Maybe I need to mention that DC cloud is more and more important, and it generates typically much bigger packet than normal subscriber. It's additional probably challenge. And maybe I need to mention that on the receiver side, we still have default on the receiver host. We still have default buffer for reassembly 1500 bytes, which is maybe limiting if you will see that the minimum packet size for IPv6 1280 and 1500 is 220 byte overall. It's again could be limiting in some particular situation. Hence, go next slide, please. We did investigation. What could be the solution? Okay, it's one again investigation, because probably discussion what to do about oversized packets did happen already many times. But okay, let we see what we have here. Of course, the best choice is to increase MTU on your all network links and don't have problems of oversized packet at all. Okay, it's an excellent solution. Unfortunately, it's not always possible, and it has not just some temporary problem like, for example, outdated hardware, for example. Yeah, it's additionally, or middle boxes, for example, they typically don't support a big enough MTU. It has some fundamental problem. For example, one of big fundamental problem is buffer inefficiency. If you have cheap platform chip, it's something like low-end router or any switch, almost any switch, okay, most of the switches. If it's low-end hardware, cheap hardware, then the buffer typically constructed in such a way that one packet, one buffer. There is no split like ATM, there is no split and reassembly inside the memory. Hence, the memory could be occupied extremely non-effectively on majority of low-cost platforms. And if in this situation you will install the big MTU, then it means that 9K buffer will be occupied by, okay, maybe not 64, but even sometimes 64 byte packet will occupy 9,000 byte buffer. It's a principal problem which is not easy to solve because it's a cost. Of course, high-end platform is capable to split big packet for smaller packets, and smaller packets put in the buffer, and then memory is effective. But for low cost, if you will increase 6 times the size of the packet, then you will decrease buffer size 6 times. And if this platform in general has 15 milliseconds of buffer for wire speed, then after 6 times less, 3 milliseconds, any burst from video, for example, will immediately get a drop of the packet. Hence, it's difficult to solve this problem. And maybe the problem organizational, for example, the link could be from third party. Link could be one telco rented link from another telco, then it's not possible to change MTU. Or maybe the situation then we have non-Ethernet technology, wireless, for example, where MTU in principle is not so big. Next slide, please. Okay, additional option which we potentially have, we could be careful about attachment of additional information to the packet. Be frugal. I see a lot of activity in reality. Most of activity currently which I see in IETF is about this particular solution, because I have seen already many publications for transfer of MTU information by ISIS, by BGP-LS, by PCP, by SR policy. There are a lot of ways how to understand MTU, especially on controller side, and then controller could understand in particular situation what is possible to attach, what is still oversized and what is still not oversized. It's not universal solution primarily because of ECMP. If it's fully controller managed, something like SRT, for example, then all path is well known for controller, then of course it's possible to predict MTU. But if it's distributed architecture like we have right now for majority of cases, if every node make a decision about next hop forwarding by itself, then prediction for a CMP calculation is extremely difficult if possible. Hence, it's not universal solution. It needs upgrade of everything, but in some situation it could be useful. Maybe one additional problem which exists that sometimes we attach headers not on the tunnel side. There is no virtual tunnel interface where we attach headers. It could be the case for beer, for doesn't matter which one, IPv6 or IPv4. It could be for IOM, for example. It's not always virtual interface, and then it's not. If it's not virtual interface, then such mechanism will be much more difficult to implement. Hence, okay, maybe it's possible, but again, it's not a universal solution. Go next slide, please. It has been discussed already many times why fragmentation is very bad. But here in the draft, we did analysis about all current implementation of tunneling. It's about 10 different type of tunneling in PLS, LTTP version 3, VXLAN, etc. We have analyzed. Unfortunately, fragmentation is mandatory for one corner case, unfortunately. If your packet is already smallest one, it's already 1280, you could not send PTB message to the source. It does not make sense because the source will not decrease packet anyway because it's already minimum. It's not possible. Hence, unfortunately, we need fragmentation for this corner case. And this situation is unfortunately properly explained only in the oldest tunneling RFC. It's RFC 2473. It's a PV6 inside the PV6, the basic tunneling specification, which, by the way, referenced by SRH. SRH just has small comment that SRH is based on this particular RFC. In this RFC, we have in reality a good explanation of what to do about this situation. If we look to all other tunneling specification, then in majority of them, we have just a discussion that fragmentation is prohibited. No any discussion what to do if it's already 1280 smallest packet, what to do in this situation. No discussion. In some, there is a discussion. There is a that okay, we have the situation. Of course, it does not make sense to discuss too much. I have references here why fragmentation is bad, because there are some number of good recent drafts of RFC which explains why fragmentation is very bad. Please go next. PathMTU discovery still looks like the best solution, most universal. Hence, it's still probably primary one against oversized packets. It is, again, best described only in the RFC 2473, 22 years old RFC, because only this RFC has deep explanation how to do effectively proxy. Okay, this particular RFC does not have name proxy. It's a terminology which is not available in this RFC, but effectively it's proxy, because what is explained in this RFC, if you will receive PTB message, packet to big message, from inside the tunnel, then you should not just change your virtual interface MTU. Additionally, you should recreate the PTB message and send to source. In this way, the real source, the real host, has a chance to change the size of the packet by one round trip time. Because in many other cases for other tunneling technology, which I explained in this draft, for other tunneling, unfortunately, we have an explanation that only the MTU of the virtual interface itself should be changed. No any immediate feedback to the real source should be sent according to many other standards. Then it means that we need to wait next packet from the source, and the next packet would be dropped, or this time it would be dropped not inside the tunnel. This time it would be dropped in front of virtual interface, and then we'll have chance to report PTB by the next round trip, report PTB to the source, and source could shut down. This PTU discover PathMTU discovery is friendly to massive equal cost multipath, which we have right now in the network, because even if it will change dynamically for some situation, then it would still operate. It would still be possible to use it. Probably it's still the best solution. Please go next. Additionally, some of you, of course, could point to packetization layer MTU discovery, but packetization layer MTU discovery itself claims that it's not a replacement for PathMTU discovery. It claims that it's a good additional tool, but unfortunately, it's only based for one application. It's difficult to share between applications, and it could not work if we have a massive drop for just overloaded link, for example. It has some other problems. It's not a replacement, but it's augmentation for PathMTU discovery, which potentially could be used. Okay, go next. Go last slide. The conclusion is just evident that if you have the capability to increase MTU, if it's really possible, then just increase MTU and then it's fine, it's excellent, yeah. But if it's not, then probably PathMTU is your next choice as a solution. The fragmentation probably is not a solution at all, and PathMTU and packetization layer PathMTU discovery is probably is a good augmentation for all of this story. Of course, document has much more discussion. I mean, much more details. But for the presentation for IETF, that's probably it. Now I see Gian is asking question.
Yes, Gian.
Yes, sure. I had a question. So, I guess you mentioned in your presentation about various overlay technologies, and there is, quite a lot out there, as you mentioned, VXLAN, MPLS, beer. There's so many overlay technologies that do require a higher MTU, so you end up, having a larger overhead. At least on the transport side, that the core, and even aggregation layers, really need the higher MTU. Have you seen maybe, as new overlay technologies that kind of has become really the paradigm and just really the change in the market, that really just about anything you have out there has some kind of overlay. So you're always having some kind of overhead that has jumbo frames, at least from on the internet, because I guess you have the different types of networks, let's say enterprise, internet, or even let's say private MPLS or segment routing. Have you seen or noticed that maybe there's less fragmentation, and also maybe less issues related to with I guess dropped packets, or issues related to oversized packets?
But it's look like not a question, it's look like a comment, right?
Yes. Yeah, I guess comment.
Gian, thanks you for your comment, because you have reminded me something important which I have forgotten to mention to support your idea even more. I could say that right now, because data plane in general, forwarding plane, data plane has become much stronger compared to control plane. We see right now a lot of movement of some tasks, some functionality from control plane to data plane in general. Not just it's related to tunnel, for example. It's related to everything, to quality of service, to many things. And as this movement, typically it does not create a huge challenge for data plane, because data plane has become much more strong for last 20 years, but movement from control plane do two good things. One good thing, that control plane has become much simpler. There is a synergy here, because the data plane tolerate this, but control plane is becoming much simpler. We see this story, and additionally we could organize some new number of services which was not available before. Hence, yes, I could even expand your comment that it's not just about tunneling, it's about everything. We just have right now the trend on the market to move many things from control plane to data plane, and then it means that more size in the headers we will need.
Thank you. I just had one last comment. We know with IPv6, because you do have a comparing, I guess, apples to oranges, I guess, like IPv4 versus IPv6. You're doubling the IP header. And then your maximum segment size, now it actually shrinks down. It's almost like you're doing GRE tunneling, but you're adding an extra 20 bytes. So that's a quite a big change. And now you have all these extension headers. So that overlay, I guess if you look at it from a, comparing to, let's say, overlay, IPv6 in itself, just by itself natively, it adds a tremendous overhead by itself. And you're not even taking into account overlays. Have you seen and maybe a trend in the market that, or industry, that as, I guess, let's say internet service providers and whatnot start migrating and pushing towards IPv6, everyone's going towards super jumbo, like at least 9,000 or higher MTU. I mean, I know, let's say Verizon, I guess, for an example, I mean, we run super jumbo like throughout Verizon. And I'm sure other providers as well, like Lumens and some of the major tier 1, tier 2, tier 3 are running, at least from a transport's perspective, they are. But then as you get down to the smaller service providers, maybe not as much, but I would say probably from the larger providers, that are actually pushing to go like V6, so you have V6 everywhere, that's kind of becoming the case. Thank you.
Okay. Jen?
Hello. Disclaimer, I did read the draft. Maybe I misread it, but I got an impression that the key problem in the draft is that reassembling buffer is 1500. And I am not sure if it's just theoretical statements or you've seen any practical real life evidence of this, because to be honest, in IPv4 this value is 3 times lower. It's 5676, right? But it only means the minimal number we can expect from hosts. And from what I saw, most of modern operating systems are easily reassembling up to 65K packets. So I agree that RFC 8200 may be not so clear about, like, maybe a bit pessimistic, I should say, about hosts should not be sending more than 1500, but I don't think it's what's happening in real life. So I'm just curious, how big would be the problem you describing if we assume that hosts are capable of reassembling big packets? It's my first question. And second, I'm just curious, my experience being that you assume that internet MTU is 1500 or maybe even 1280, but most of the operators I've talked to which have overlays in their backbone are capable of running much higher MTU. So mostly all these small MTU links are interconnects. So do you think it's still a problem for overlays having like not enough MTU on the link?
Let me start from second question because it's much easier. For a long time, because restriction on the Ethernet level, because any size above, if I remember correctly, 1536, I have stated in the document, everything is what is above has been treated as a type, not as a size. And for that reason, for a long time, 1536 was really a restriction, and for that reason, it's still the case with many links in the internet are provisioned, not just internet, everywhere is provisioned as something a little bit smaller than 1536. Therefore, the second question is definitely yes. It's still the case in many cases because it's enough for MPLS, definitely enough for a few labels. For many labels, it's enough. But as we start, instead of labels, to put enhanced headers, especially such long as bittings replication beer, it's already not enough. For second question, answer is positive. For the first question, I have two answers for the first question. The first answer, it's not a big deal that we have just 220 bytes between reassembly buffer and minimum packet size, because it's related to the host. And majority of features which we have started right now, SRv6, BA, whatever, it's all features which is related to intermediate nodes. It's not for host. Therefore, this particular reassembly buffer, it's stated, by the way, in the draft that it's not a problem yet. It probably would not be a problem for many years to come. It's stated in the draft. It's a positive answer that it's probably not yet a problem. But for the second answer to your first question would be, I need to search more. I need to investigate more, because I am not sure about the majority operation system, Linux, what we have on the market. We have Linux, Android, Microsoft Windows. I need to search more, because I'm not capable to answer first your question properly. I will answer your question later. I'm not ready right now.
I can tell you that I did test yesterday. Linux, macOS 11, and Windows 10 were perfectly fine with 65K packets arriving. Not under load, but theoretically. And actually, the funny thing is, I agree that 8200 a bit like not as clear as IPv4 fragmentation RFC, because IPv4 actually, for IPv4, it clearly states that it should not be constant for operating system, and the host might have a kind of continuous buffer. And I would be surprised if modern operating system do IPv6 reassembly different than from V6, from V4, but I am not really an expert here, so maybe the group could comment on this.
Okay, I'm sorry, I'm going to have to cut off discussion here. We have 2 more drafts and 9 minutes to go through them. So if we could bring discussion of this to the list, and if the next presenter could go really fast and will also bring questions on this draft to the list. Do we have a next presenter here? Yes.
Yeah. Okay, you can't hear me? Great.
Yes, Nick.
Okay, so basically this this draft is to address an operational issue that some of us that are prototyping and deploying very large networks are running into, and it essentially comes down to adding a dedicated prefix for use in lab. Now, there's actually 2 drafts. I think we're only going to talk about the lab prefix in here. There are 2 slides if we want to, but I don't think we'll have time. So could you go to the next slide? Okay, so folks can go and take a look at the draft. The TLDR is that we are asking, to dedicate GUA space out of some deprecated, out of a deprecated prefix. It's a /7 that would be dedicated to prototyping and lab utilization, so that we can have GUA space that operates just like a normal production GUA-based network would, but allow us some padding and some other niceties for building it in a safe environment, and also allow the sharing of these labs, because that's becoming more and more common between folks with there needs to be no changes to lab files, configurations, and things like that. So in the past, it's been typically done with whatever you can scrounge up to cobble together what space you need. But now that there's been more frequently institutions are being allocated things larger than /32s. And that makes it very hard to lab things up. In addition to that, using ULA space doesn't really provide a terribly useful platform because of RFC 6724 precedence values. So if you're planning to do V6 only, you can maybe get away with that. If you're planning to do dual stack, which I think is what most environments are looking at, it becomes an impediment because you can't properly test a dual stack environment in a way that it would operate in real life with GUA space. So we've gone through and addressed a bunch of the the things that have been come up on the list. We think this is a -01. It's actually already been incremented to that as of late last week, and we look forward to any input on that. We think it's a very useful operational tool. If we have time, which I suspect we don't, we can talk about the additional documentation prefix, which is a separate.
Yeah, we don't have time to talk about the additional document, but I think Bob has one quick comment.
Sure.
Yes, thank you. Yeah, I don't understand why you just don't use ULAs. I mean, they give you lots of address space. You can get as many as you want. You don't have to worry about them leaking. You know, we're not going to create another kind of private addresses. I don't think I support this idea.
So if you're building a dual stack network, ULA does not function in a usable way, because say you're building a network that is a prototype for a service provider, and you're dual stacking everything, and you're building it properly like you would build a production network, you're going to use DNS. When you use DNS, you will always use the IPv4 addresses, which does not mimic reality when you're trying to lab things up. So ULA is depreferenced.
Okay, if we could bring this conversation to the list, but I do think
just real quick, Bob, if you look at the list, I have an example that's been posted to it that is exactly this behavior in my lab, and it is very much a thorn in my side when I try to do things with ULA.
Okay, but I think what you're asking for has a whole bunch of really big negative downsides too.
Yeah, let's bring this to the list.
I look forward to hearing what you think those are.
I think this is the significant question. Xuping, you're up.
Hi, this is Gian. I'll be presenting for this draft. Can everyone hear me?
Yes.
All right. So I'm providing just a quick update for the draft. Go ahead to the next slide. So, so the motivation for this draft is I guess, as we all know, we've had Chad, on the mailing list related to HVH and the issues related to HVH, and being able to leverage HVH and use HVH for new services, but the problems related to HVH and making it actually viable. So what we've done is we've repositioned this draft, removed the anything related to solutions in this draft, and so it's really just problem statements. So that's really kind of the major updates with this draft. So with that, so HVH options header. So really, as I mentioned, the big thing is being able to use making it viable, making HVH options viable. So, and it is a valuable container for hop-by-hop processing of new services, IOAM, AltMark, PMTUD, and there are probably many others that would be coming and would more to come as HVH really becomes a viable option to use for developers. The HVH options header, it's really rarely utilized in current operator networks, and really the big issue that's kind of the long-standing of the problem with the control plane and the denial of service, with the control plane and the punch from the forwarding plane to the control plane. So that is the big undesired impact of HVH options. And I guess in the industry where a lot of providers, even on the internet, just due to fear of having a possible DDoS attack, block HVH. So even valid, legitimate HVH really can't make it across the internet. So our main goals and purposes basically to break that endless cycle that results in HVH becoming a DOS vector, enable HVH options to be utilized in a safe and secure way without impacting the management plane, and easy deployment of the new HVH-based network services in a multi-vendor or operator environment that can now be deployed without operational impact. Next slide. So we've had a few revisions, so we'll just go through some history. So in revision 2, so that was at the end of last year, we removed the solutions from section 7, so the draft is focused on the problem statement only for V6OPS. In revision 4, which was June 30th, so not too long ago, we removed the proposed processing behavior that we had. So initially in December, we removed the solutions, but we still had a proposal that we had in 6-man, so that we've removed. And really, the goal of this draft now, it's for any solutions that are out there. We want to have the work group kind of come together, and that everyone is in agreement that this is a problem that we want to solve, and we want to make HVH viable. And so this draft, the goal is really to help pave that way, to, for everyone to come to agreement, make this a work group draft document that the work group can work on, and that would actually help pave the way to actually any solution, not just the solution that we have, that possibly, but really any other solutions that are out there, including like Bob's solution that he has with a single TLV options, sort of limiting the number of options, and there are other viable options that are out there, but we want to make it open, but really come to a consensus that this is a problem, and it is a problem that we want to solve. In the last revision that we had, and it was just recent, we just changed the section 7 from desired processing behavior to requirement. So we're just kind of making it official. So this is an official document, and we're really ready. I think with the changes that we've made in the last few, we really feel this document is ready for work group adoption. So any comments or questions? Thank you.
Well, I think the first action item is for everybody to read the draft that was posted on Monday, because that really makes a significant difference. I don't see anybody in the queue, and our time is exactly up.
All right.
So, any parting shots by anybody about anything? Okay, thank you all attending. Barbara, thank you for helping with the minutes. And see you all on the list.
All right. Thanks, Ron.
Bye now.
Bye.